Okay, hello everyone. So I'm going to talk about two convolution problems. Okay, so the first one is shown on this one, the convolution of two rectangular functions. The other one is a rectangular function and segments of exponential decaying function. Okay, so let's get started. So the first one, if we want to solve it, probably we need to know what is the definition of the rectangular of T, right? So rectangular of T is what we have used in this course very often. So this is one at between -½ to +½ right? And then 0 elsewhere. Okay, so this is our definition for the rectangular function. I can probably move it to here for reference. Okay, now x of t is just a rectangular function, no problem. Okay, h of t, we want to take a look what it is. What's the shape of it? Okay, so first thing is that we observe here we have a 2 in front of t. So basically we have a compression of this original template. And then we have a subtraction of something. So it looks like we are moving it to the right, okay, but not by 1/2, okay? So we are moving it to the right by 1/4, okay? You need to take out this 2, okay, first, and then it becomes 1/4, okay? So let's demonstrate that. So h of t is actually a rectangular function of 2 t minus 1/4. Okay, so the moving amount to the right is actually the amount subtracted, okay, directly to the variable of interest, not the amount that you're seeing within this pair of parentheses. Okay, so I've mentioned this multiple times in our class. Okay, so first thing we are going to draw a condensed version, right, of this one. Okay, so the rectangular function. So the rect2t, the horizontal axis is t, is actually condensed version. So previously it was half, right? Positive and negative half. Now it is positive and the negative 1/4, right? So it's narrower, the height is still 1, right? And the second step is that you're going to move it to the right by 1/4. So this one negative 1/4 becomes 0. This 1/4 becomes 2, right? Okay. So anyway, so you have a function that is narrower, right, than before, and shifted to the right by 1/4. Okay. So 0. This is 1/2. Okay. Here's t. Finally, you can write the rect of this thing, right? I'm going to just write this version of 2t minus half. Okay, so this is what? This is h of t, right? Right, so this is what we have. Before starting to solve the convolution, we already know what is the graph of the x of t and the graph of h of t. And then the next step is to determine, so when I want to expand this convolution, am I going to do it like expanding the x or expanding the h, okay, first. So they are different, because if you want to expand the first, if you write this version, okay, then usually what you want requires that, okay, x of t or x of tau is a more complicated form, while this one is simpler form. Because in this simpler form, you plug in this t minus tau, it becomes more complicated. So neither of them is overcomplicated, right? But in this case, it doesn't look so well, because this x of tau is already very simple. So h is already complicated. Then you make it further complicated. So we actually would prefer to do this expansion, which actually means that by definition, we are going to do h of t convolve with x of t, right? So the convolution operation commutes. So we have no problem doing that. Okay, now let's plug in the things. H of tau is rectangular of t, right? And the x t minus tau is going to replace, sorry. So h of tau is actually this whole thing, okay, rectangular 2t minus 2. And the x of tau, x of t minus tau is going to replace the t by t minus tau. So that's the rect t minus tau. Okay, so d tau. So you can see that here, the integration bound is still r. So you can see that this one, this h of tau is now going to change, okay? But the rectangular function of t minus tau is going to be the rect t, okay? We are going to flip it and we are going to slide it, okay? So graphically, we have this guy is this guy, and we want to change the variable here, and then redraw the figure to avoid confusion later. Okay, so I will use a different color for this one. Okay. So it will be from 0 to half. And this is tau now. Okay, so this rectangular is 2 tau minus half. Okay, so I will just write it h of tau. So this is our h of tau. You can see this one are completely the same, except your dummy variable is different. Okay, and then rect t minus tau. So it's going to be a flipped version of the original one and slide it along, okay, to the right. Why? Because let me use another color. This one is actually the rectangular function of negative tau minus t. Right? So this negative tau plus t, so they're equivalent. So you're going to first, to arrive at this function, you're going to get the rectangular of tau function, and then you flip left and right, you get rectangular negative tau. And then you slide it to the right by t steps. Okay. Maybe I should move this to here for now. Okay. So you have the rectangular t here, right? We can change the t to tau, doesn't matter. So let's assume this is tau. Okay, and we flip left and right. It doesn't change because this is symmetric one, right? Now I write rectangular negative tau function. Right? And then I move it to the right by t steps. Previously it was negative half, now part half, right? We move this point to the right, so this point becomes half plus t, right? The horizontal axis is tau, and here this point will become what? It will become negative half plus tau, right? Negative half plus t. Okay, so just t minus half. Okay, so that is easier to think about. Okay, now, so this is our finally required version. Okay, so what is this? Okay, this is actually xt minus tau. I just write it xt minus tau here. Note this xt minus tau graph is actually a function of tau now. Okay, so you're going to multiply this h of tau, okay, h of tau with this x of tau, right? You're going to multiply them and then you're going to integrate, right, some of the area under the curve. Right, so now let's get started with doing that. You can see that the burden here is that we don't know how much movement we need to do for this function, right? So maybe this kernel is going to align. Let me just move it. So maybe this kernel is going to on the left-hand side of this kernel, or maybe this one is going to be on the right-hand side, right? Or maybe this thing is going to overlapping partially with this one, or overlapping partially with this side or completely, this one will be completely covering the range of 0 to half, because this one has a width of 1, this one has a width of half, right? Okay, so these are the cases we needed to discuss, and then let's get started, right? So I still, let me, for the sake of clarity, I move things back. Okay, now, so let's discuss different cases. Okay, so we call them different subintervals. Okay, so let's say this is our x and this is our 0 to half. Okay, and then I can, in the first case and in the last case, it will be like this one. So they have no overlap. So this is one case. So the endpoint here on the left is t minus half, on the right is t plus half, right? So in this case, in order for this scenario to hold, we need to make sure the right end will be smaller than this left end, right? So that will be have a less than equal to, less sign, okay, or less than equal to. So that's t plus half less than 0, which leads to the first condition that we have, t less than negative half. Okay. And of course, we have another scenario. Which is, as I said before, the blue kernel is on the right hand side, right? There's a tau, and here the cutoff point is t minus, right? The left edge, left end. So this point is on the right of this half. So we have a greater than sign here. We need to write half less than t minus half. So that means t must be greater than 1. Okay, so in both cases, we can actually see that, oh, if I multiply this function and this function, right, as we require here and here, so we get 0 here, 0 here, 0 here, all the way 0, right? So essentially we can write yt equals to the integration of negative infinity to positive infinity, h of tau is 0, xt minus tau is 0, d tau, and everything is 0, right? For t less than half, right? Another thing is same, okay, so let's just write it, y of t equals to 0 for t greater than 1. Okay, then we have other corner cases. Okay, so we have 3 other cases. Let's be patient. Here's 0. Here is half. Okay. So the blue one is going to, first, the blue one is going to overlap with the left part of the black window, right? So you can see here, so this point is actually t plus half. And this point is actually t minus half, right? So this window can, the blue window can move all the way to the left until this point touches 0, right? Or this point can move all the way to the right to half, right? Still, we are overlapping with the left part of this black window, right? So this is the condition. So basically what you need is 0 must be less than t plus half, less than positive half, right? So this point must be bounded by left and the right ends. So that's why we have this equation. So because of this, we have t greater than negative half, less than, right, 0. So this is another subinterval, right? And further, we can continue. We have this one, right? So we have another one that window, the blue window overlaps on the right part of the black window. So this is t plus half. Okay, so this is t minus half, right? So in this case, this t minus half is going to be, right, greater than 0, less than half, right? The window can move left and right, just from here, all the way from here to here. Okay, so that's right, t minus half greater than 0, less than half. So which leads to t greater than half, less than equal to less than 1. Okay. Okay, so the last condition is that we have the blue window completely covering the black window, right? So the left end t minus half, right end is t plus half. Okay, so we need as t minus half is less than 0, right? So this point is on the right of, on the left of this point, and then we have half less than t plus half, right? So these two, and then leads to t less than half greater than 0, right? So we have a lot of those intervals. Why it's disappearing? So this is 0 here. Right? So let's see if all the intervals, if we union them, whether they become the real line, right? So this is t less than half, and then here from half to 0, from 0 to half, from half to 1, and then from 1 to infinity, right? So we actually have all of them in union, and then they become real line. Okay, so that's great. So let's calculate the detailed integration here. So y of t, that's just the black ink. Y of t equals to integration. Original was from negative infinity to positive infinity, but because both of them are going to be 0 outside the common range of, the common range is actually here, right? 0 to t plus half. And then both functions are 1 here because they're rectangular function, and then d tau, right? And then integration and the d tau, they will cancel, right? So integration d will cancel, and you leave with a tau, right? And then you have tau 0t plus half, right? So that's final result is t plus half for this interval. Okay, another one, yt equals to integration. The common interval here is from here to here. So that's from t minus half to half, right? And the 1 e tau, right? So if you're confused, what's a 1 is a 1 is, so this h of tau is 1, this x of t minus tau is 1, because, right? So this is a 1, this is the other one. Okay. They have tau, and then t minus half to half. Okay, so half minus t minus half. So that's 1 minus t. Right? So finally, you have the interval that is easy because the common range is from 0 to half. Right? 0 to half, and then you have 1 times d tau, so that's half. Okay, so this is what you have, and finally, you need to have a good habit to put them together in order. So this is t less than, I forgot, t less than, the first one is t less than half, right? The second one is t greater than half, less than, greater than half, greater than negative half, what's it? Here, right? Less than 0, right? And the third one is t greater than 0, less than half. And then we have t greater than half. That's it. Okay, so t greater than half. Or t greater than half less than 1, and then t greater than 1. I think that's this interval, and the t greater than 1 is this interval. Okay, so you put them together, and then equality sign for integration doesn't matter. So usually we put them on the less than equal to sign. Okay, so that is how we finally put results, and then you copy things here, and you're done. Okay, so this one from 0 to half, you have half. Okay. From half to 1, you have 1 minus t. Okay, greater than 1, you have this. Smaller than equal to negative half, you have 0. And just try to find it. Okay, t plus. Okay, so this completes this problem. Okay, so I will stop here.